Hi geometry guys, we are back with part 2 of 8.1 circles and chords. Yesterday we identified what a chord was. We talked about what it looks like on our circle, some of the properties of the relationship to a radius, and any line that ends up being perpendicular to it. So today we're going to go a little bit further and we're going to talk about if we have two congruent circles. That means that they are equal to each other in dimension. This could also be that they're the exact same circle. So this is true for congruent circles or the same circle. So if you have two chords that are congruent, then we also know that they have to be equal distant from the center. So our theorem technically says in congruent circles, two chords are congruent if and only if they're equidistant from their centers. So what we know, let's turn this into some real talk here, is that if these two circles, circle A and circle B, if they're congruent to each other, then what we can also, I guess we also need some letters here, huh? Let's call this C, D, and E, F. So if we know that CD is also congruent to E, F, then we can say that our distance is also going to be the same. So this teal line here that's dotted, line AC, is then going to also be congruent to line BE. Okay, I guess you also could say that this distance here is also congruent, okay, and either way it kind of goes back and forth, so it doesn't really matter whichever one we have. We also then know that this distance here, let's call this X and call this Y. We know that AX is going to be equal or congruent to BY. Okay, that's this section here. It's the same distance away. Okay, so it doesn't matter if the chord is down here at the bottom. It doesn't matter if it's on the side. You can rotate the whole thing, and there are so many things that are similar and congruent. Once you have it proven to say that you have AX equals BY, or is congruent with, and if these radiuses are also congruent and the chord is congruent, we know that it's bisected. There's so many things. We can prove a lot of things just by having that information. Okay, let's try an example here. So we need to find AB and GF. Those are the chords that we have in these two pictures here. We know that CD is congruent to HI. So let's make those green. CD is congruent to HI. If you want to follow along, this is on 347, example 2. Okay. We also know that CE is equal to HJ. Okay, so let's say CE is equal to HJ. Okay, and we know that AB is equal to 5y minus 3, and we know that GF is equal to 2y plus 9. All right, so the other piece of information that they should have clarified at the beginning is that these are congruent circles, okay? So if these circles are congruent, we know that their chords have to not only be equidistant from the centers, but are also going to be the same. Okay, if we know they're the same, they're equidistant. If we know they're equidistant, we can decide that they will be the same. And so right now we know that they're equidistant from the center. If CE and HJ are equal, look, this is the same distance from the center. So now I can assume that the chords are congruent. So now I can say, hey, AB is congruent to GF. And if they're congruent to each other, then we know that they're equal to each other by the property of just equality there. So we also know then 5y minus 3, I'm just plugging this in here, is equal to 2y plus 9. And now I'm left with a basic algebra problem. I'm going to try to get my variables on one side, so I'm going to subtract 2y from both sides. That gives me 3y minus 3 equals 9. And I'm going to kind of move over here a little bit. Now I'm going to add 3 to both sides so that I can get this eliminated. I'm going to have 3y is equal to 6, divide by 3. So y is equal to 2. All right. And now what I wanted to know was how long AB is and how long GF is. Well, if I know that AB is equal to 5y minus 3, and now I know that y is 2, I can plug that number in. So AB is going to be equal to 7. And if, hang on, I don't think that's right. I definitely did something wrong. You guys catch this? Sorry, I just kept rolling. You're probably sitting there laughing at me. Tip number 1, don't do math late at night. It's probably, I don't even need to tell you what time it is. It's pretty late. So that's your first tip. If it's late for you, maybe you should pick this up in the morning. 9 plus 3 is not 6, it is 12, which means that y is 4. Okay, well then let's try this. Let's make this be 4, which makes this 20, and it makes this 17. Is that right now? Okay. If AB is 17, now you can plug it into GF also and say that GF is 2y plus 9, but we know that they're the same, so we can just say that they're 17. But if you want to check, you can check. 8 plus 9, yes, that is 17. Okay, so now we found both AB and GF to be 17. All right, example number 3, our last example for today, so hang in there. All right, we've got a circle, and we've got 2 different chords on it. We've got chord AD, AD and GE. So it's got to be that the same rules apply, that if the chords are congruent, they're equidistant from their centers, or if they're equidistant from their centers, we can decide that the chords are congruent because it's on the same circle. So these circles are congruent to each other by the fact that it's the same circle. So the first thing that we know is that we're looking for CH and HB. So I want to know CH and I want to know HB. Okay? Now what I do know is that AD, this chord, is equal to GE. AD is equal to GE. And they equal 10 centimeters. All right, so if this whole thing is 10 centimeters, we know that if we have some sort of a chord and this line, so we've got this FC line here, right here. If it goes through the center, which they both do, what do we know? Well, if it goes through the center and through the chord, it's got to be perpendicular. And same over here. So this line here, CB, it goes through the center. So therefore, we know that it's a right angle also. Okay, so let's throw that in there. A radius that's perpendicular to a chord is going to bisect a chord. So this purple line, because it is creating that 90-degree angle, is going to then bisect it. So this is cut in half. So if this whole thing is 10, well, half of it is 5, and this half is 5. So that means over here this is 5, and it means this is 5 because I know that they're the same. Well, the other piece of information that I have here is that this distance is 13. Okay, so if I know that this distance is 13, I can apply the Pythagorean theorem. And once I apply the Pythagorean theorem, I can find this piece of information here, which is going to be the same as my CH. CJ right here is going to be the same as CH, because I know everything here is going to be similar to everything up here. Okay, so I need to use the Pythagorean theorem. I've got this triangle right in here. I'm going to draw it out over here so we can see it a little bit more clearly. I know that the hypotenuse is 13, and I'm looking for this height here, and I know this to be 5. Alright, this should trigger in your head another Pythagorean triple. You could take 5 squared plus my question mark squared and equal 13 squared if you're using the Pythagorean theorem. You could also use the formula that we wrote out, that b is equal to c squared minus a squared. And when you plug all of that in, you're going to find that our missing side length over here, we'll call it b, is equal to 12. And the reason I can jump straight to that is because I know our Pythagorean triple of 5, 12, 13. Again, saves you so much time doing that whole thing there. So we know this distance is 12, which means we know that CH is 12, which is one of the things that we're looking for. So we already know that much, which is awesome. So CH is what we were looking for. We were also looking for HB. We know this is 12. I guess they're centimeters, right? Okay, so we're halfway there. Okay, well, what else do I know? HB is this little guy right in here. I know that this whole thing here has to be 12. Oops. Okay, there we go. 12 plus a little bit more, right? Well, CB is going to be a radius, isn't it? Okay, well, CB right here, it's getting a little messy here, I'm sorry, is a radius. Well, isn't this also a radius over here? And isn't this a radius? And isn't this a radius? And aren't all of them radius, all the radii going to be the same? So if this whole distance is 13, I'm going to clear this up a little bit here for us. This whole distance is 13. And I know that I've used 12 up. How much is left over? How much is this little remaining portion? Well, it's got to be 1. 1 centimeter, 13 minus 12 is equal to 1. Oops. There you have it. All right, I want you to turn to page 348. And I want you on your own to try numbers 10 through, let's go to 17. All right, pause this video here. I want you to give these a valiant effort. Come back to the video later. Check them if you have time now. Finish out. But you need to try these on your own, and then we'll go over them together. Okay, how'd you do? Hope you were able to feel confident with some of these. Let's take a look at this work, and then you will be done for the day. Tomorrow you have a Desmos activity. Friday is a catch-up day, so you were almost there. All right. Number 10 says find H. Let's get my pointer out here. Find AH if AD is equal to 4. Well, here's AH. And here's AD. Well, if this green line is equal to 4, it's a radius. Well, all the radii must be the same. This is also a radii, so it should also be 4. And there's no unit of measurement, so just leave it at that number. Okay, yeah, that one wasn't so bad, right? Number 11, find BC. Now this half of a chord, and I'm telling you half because I see the perpendicular symbol, which makes me think automatically, hey, these guys have got to be bisected. So you could even have the little lines if you want. I guess I can't assume that they're all the same at this point. There we go. Okay. So what we know is that BC is equal to BE. No, we know that BC, we're looking for BC. Oh, goodness, sorry. Again, don't do math late. BC is equal to CE. Okay, and what we know is that BE, this whole long thing, is 18. Well, if the whole thing is 18, what's this top half of it? 18 divided by 2 would be 9. Number 12. Find FI. Again, the hardest part, I think, is just finding which section you're looking at on here. So find Fi, the section here, if AG, this distance, is congruent to this distance here, AC. So what we're looking at is, I'm going to grab another color here. This part, that's a terrible little bracket. There we go. That part here and this part here, ooh, there we go, are equal, which means that those chords that are yellow are equal distant from the center, which means that they are congruent chords based on our new bit of information. If they're congruent, then we know almost everything about these sections are also going to be congruent. Okay, so we know that BE is equal to 12. We know that this part is the same as this part. Well, if this is 12 and they're both congruent, what is Fi? Well, it's also going to be 12. The answer to 12 is 12. All right, number 13. Again, bear with my terrible writing on these things. All right, find AG, this section here, if Fi equals 16. So we're looking for this. And put a question mark here. And we know that Fi, this whole distance here, is equal to 16. And we know that AC is equal to 6. So we're looking for AG if Fi is congruent, or is 16, which is kind of tricky because they're giving a little bit extra information here. Oh, let's see, Fi is equal to 16, and BE is equal to 16. Okay. So we know that the chords are equal, which means they have to be equal distant. So if this one is 6 away, then this one is also, you guessed it, 6 away. Okay, let's get rid of that so we can look at their next one. We'll put this 6 back here. Okay, number 14. All right, find BE, this whole distance here. Find BE if AG and AC are congruent. We love when that happens. If this is congruent to this section right here, then we know the chords have to also be equal. If they're equal distant away, they've got to be congruent. And I know that IG is 10. So IG is 10, which means GF is 10, which means FI is what? You guessed it, 20. So if this yellow chord is 20, then BE over here is also going to be 20. So let's erase some of that, put our answer in here. All right, number 15, how you holding up? AI, now this is a line that we don't have on here yet. I'm going to add it as a dotted line. It's going to be another radius, so it's going to be equal to AD and AH. Find AI, that's what we're looking for. If AC is congruent to AG, that means they're equal. The chords are equal distant apart. We know that the chords have to be equal. They're in the same circle. If BE is equal to 10 and AC is equal to 4. Okay, so what's really happening, if this whole thing over here is 10, then I know that half of it is 5 and half of it is 5. But because they're equal distant away, this whole section is going to be congruent to this whole section. So I can use those same numbers. This is going to be 4, this is going to be 5, this is going to be 5. Well, look, this is beautiful because what do we see here? We have a right triangle. This right triangle, let's come down here. This right triangle, I'm going to rewrite it this way, has a distance of 4 and 5, and this is what we're looking for at C. And we don't have a 3, 4, 5. You might recognize, hey, 3, 4, 5. Yeah, done. There's my triple. C's 3. Well, can't really say that because the hypotenuse is the longest side. It's across from the right angle, and 3 is definitely not the longest side of a triangle that's 3, 4, 5. So, bummer, right? Well, we're going to have to do the Pythagorean theorem. Oh, that's what we're looking for. So, C is equal to the square root, look in your notes, A squared plus B squared. So it doesn't really matter which leg is which. And I know some of you have probably pointed out in your brain already, to scale technically, I guess it would be like this. But according to our picture over there, it's just really not to scale. This was really 4 and 5. Either way, it doesn't really matter. Okay, so we've got 5 squared plus 4 squared. And it doesn't matter because we're going to add them together and it'll end up being the same. That's 25 plus 16. So C is equal to the square root of, 41. And there are no perfect squares that we can pull out of that. So AI, this whole thing, is the square root of 41. Okay, let me see how many things I can undo here. I don't know if it's going to let me go all the way back. Sorry, guys. All right. Square root of 41, on to number 16, almost there. Hopefully we can, can't zoom out anymore. All right, number 16 said find AB. So now we're looking for AB. Another one over here. Find AB if AC, this distance here, is 4 and BE is 6. Well, if this whole thing is 6, I know this has to have to be 3. This half has to be 3. And now we're going to do the exact same thing before, except it's going to be a little bit easier. Praise the Lord. We have a very nice, pick a different color here, right triangle. And it's a 3, 4, 5. We can use the 3, 4, 5 because 3 is one of the shorter lengths. So we can just come over here and say that this is 5. All right, number 16 was 5. We are on to our last one, number 17. We need to find HF. Finding HF if, that's this part right here, if GH is equal to 6 and IG is equal to 12. Well, IG is over here. That's equal to 12. Well, I know that this is a right angle here. So if this part is 12, what do we know about this over here? Yeah, it's also 12. So now I've got this nice little triangle. And if this is a right angle up here, I know this also is a right angle. So now I've got this tall, skinny little triangle here with that 6 and 12, and I'm looking for this side length. It's across from the right angle, so it is the hypotenuse. So I'm going to use the Pythagorean theorem again. C is equal to the square root of A squared plus B squared, where A and B are both 6 and 12. So I'm going to take the square root of 6 squared plus 12 squared. Move over here a little bit, running out of some space. Oops. So the square root of 36 plus 144 gives me the square root of 180. Now, I know that there's some perfect squares in there. I know that there's at least a couple things. I know there's going to for sure be a 9 in there, but I can actually turn this into 36 times 5, which means if I were to take the square root of 36 times the square root of 5, well, we know that this simplifies to be 6 times the square root of 5, and there is our answer. It can't be simplified any past that for number 17. Well, I hope you did okay on those. That is it for today. Again, I kind of laid out the map for the week. I hope you're doing okay. I hope you're understanding this for the most part. We will kind of assess this next week. Have a great rest of your day. Miss you guys.